Okay, so previously in mechanics we've done a lot of work around these three things. We've talked about displacement, we've talked about velocity and acceleration. We did the Suvat equations for constant acceleration, but these equations that we're dealing with in this unit are a bit more realistic. They don't have constant acceleration. Acceleration is also a function of time, and so we need a different approach. And if we remember from the first unit, we had that when we were drawing displacement time graphs, that the velocity was the gradient of that. And when we were drawing velocity time graphs, the acceleration was the gradient of that. And that's because the velocity is the rate of change of the displacement, and the acceleration is the rate of the change of the velocity. So what are they all expressions to do with? And when we're talking about gradients and rates of change, it's all to do with differentiation. So if you want to find the gradient of the displacement, you would differentiate, which would give you velocity. And if you want to find the gradient of the velocity, you would differentiate, which would give you the acceleration. So if we have one of these and we want to move down to the next one below, we are going to differentiate, and that is what today's lesson is all about. We will come on later in the chapter, we might as well mention it now, that if we want to go back up the way, if you have velocity and want to get displacement, or acceleration and want to get velocity, then we are going to do the inverse of that, which is to integrate. Okay, and that's really what the rest of this unit is about. So let's look at example 4. Example 4 shows us that a particle P is moving on the x-axis at time t seconds, so the displacement, which is x from O, is given by this expression. So x equals t to the power 4 minus 32t plus 12. It asks us to find in part A the velocity of P when t equals 3. So we're given a displacement, we're asked to find the velocity, so we're going to have to differentiate it. So the velocity v is equal to dx by dt. We'll always be differentiating with respect to time in this unit. And then we just differentiate using our year 12 differentiation skills. Multiply by the power, subtract 1. 32t becomes 32, and the 12 stays as 12. 12 disappears. The time it gives us, it's talking about, is when t is equal to 3. So if we substitute t equal 3 into that expression, that will give us the answer. V is 4 times 3 cubed minus 32. So V is 4 times 27 minus 32. 76 meters per second. That's the velocity it's moving at after that. Part B asks for the value of t when P is instantaneously at rest. Right, this expression at rest, we've seen it before, it means it's not moving. If it's not moving, it means the velocity is equal to 0. We also have this word instantaneously. That's because it's not actually going to stop. It's going to go from positive to negative, but there will be a split second when it is at 0 for the shortest amount of time. So it's like a turning point on a graph, right? We've all seen these, haven't we? So if we've got a turning point on a graph, we know that this point is when the gradient is equal to 0, but the gradient doesn't stay at 0 for any length of time. It just is at 0 for a split second, and then it starts moving down again. And that's what's happening here, and that's why they've used the word instantaneously. So when v equals 0, we've got our expression for v, it's 4t cubed minus 32. All we do is we put that equal to 0, we rearrange, get 8 equals t cubed, so we cube root and it's t equals 2 seconds. Okay. The final part of this question, part C, is asking us for the acceleration when t is equal to 1.5. Well, we have an expression for velocity. It's here, 4t cubed minus 32, that's velocity. And so if we want to find acceleration, we are going to move down, so we're differentiating to go from velocity to acceleration. So acceleration is dv by dt, right? And then we just differentiate that expression, 12t squared, right? Because we've multiplied the 4 by the 3. And the minus 32 is going to disappear. So a is 12t squared. It's asking for a value of t, which is when t equals 1.5. So we just pop that straight in. A equals 12 times 1.5 squared. And we are going to see what we get here. 27 meters per second squared. Remember to include our units. Acceleration is always meters per second squared. Velocity is always meters per second. and displacement will always be in meters. Okay, and that's it actually for this lesson. It's just a single example. So what we're going to do is we're going to do exercise 11b. There's plenty of questions to do there, but I would recommend that you just do in that exercise the odd questions. If you feel like you need a bit of extra practice, have a go at the even ones as well, but for now just have a go at the odd questions.